Good morning. Hopefully everybody can hear me. We'll get going here shortly in just about a minute or so. I'll go ahead and load things up. As always, let me know where you're watching from today, and hopefully everybody got through the windy conditions yesterday. There's a little bit of sunshine out there today, which is always a nice thing to have. Again today, talking about fronts and low pressure, and tomorrow's our big forecasting day. So I'm excited. I think that's going to be a fun, interactive deal, and everybody gets to make their own forecast tomorrow. We're going to walk through it together, and we're going to look at the data as it comes in for tomorrow. So as I'm going through all the weather data tomorrow, I'm going to collect it, and we're going to take it and use that as our forecast, and so it should be a lot of fun. So coming up for today, this is, we'll go ahead, I guess we'll start a few seconds early, but from our countdown clock here, but this is Getting Schooled, and we're going to go through and talk about, again, we're in our forecasting 2-week period. So last week we talked about radar and satellite and weather balloons and observations and all the different weather tools that help forecasters put a forecast together. Yesterday we talked all about all the conditions here when it comes to cloud cover, what each cloud type means, what kind of weather we can expect from it, and how there's a lot of ugly and scary clouds out there, but not very many of them are actually ugly and scary when it comes to the weather, which is good. And out there today, again, there's a little bit of sunshine, which is certainly nice to see. And by the way, if you haven't seen in your observations yet from last week, remember we had our observation chart. If you took, Mom or Dad took a picture of it, if you took a picture of it, send it to me right now, put it in the comments here, attach the photo. You can send it to me directly, whatever. I'd love to see all of your observations and what you came up with over the last several days or late last week. So still time for that, still time to get that in. All right, let's go ahead today and get going. Again, yesterday was clouds. Today we're talking about fronts and pressure. And tomorrow it's all about forecasting. And I am very excited about next week's space weather. So we're going to be talking about the northern lights, the science behind it, how you can see it. Also, some of the fascinating parts of space weather, which a lot of people don't know what that term is. That isn't something I came up with. That's an actual science area, is space weather altogether. And we'll talk about meteors and eclipses. So it's going to be a lot of fun next week, too. For today, though, let's get started. It's all about pressure. Pressure is something you can't see, but it has such a huge impact on the weather. And you know what? Whether you realize it or not, you deal with pressures all the time. You get a balloon for your birthday. Inside that balloon, that air, as you put more and more air into it, what you're doing is you're increasing the pressure in that balloon. That balloon has high pressure inside it. All around it is lower pressure. That balloon pops. As we know, that air flies out, right? That air comes out, and it's balancing with the lower pressure that's outside of it. So nature all the time is trying to balance out air pressure all the time. If mom or dad, the air that is in the tires of your mom and dad's vehicle, that air wants to get out. We don't want it to get out because then we'll have a flat tire and then we can't drive. And so the rubber around that tire does a really good job of keeping that pressure in. But if you run over a nail or something like that, it isn't going to blow the tire to shreds, but you're going to feel a stream of air coming out. That's the wind coming out of that tire. And essentially, yesterday we had lots and lots of wind. And I'm going to show you why. It all had to do with the air pressure that we had around the area. And this is a big L. This big L here is the lower pressure. And this big H here, well, that is the higher pressure. And in this simple map of the country, we got high pressure out west, we got low pressure out in the eastern part of the country. And so what's happening is that this air wants to go from the higher pressure. This is our tire, okay? This big area of high pressure, that's essentially our big tire. And the air wants to go from here straight over to our low pressure. That's what it wants to do. It just wants to go straight from the H to the L, from high pressure to low pressure. But then we have something else happening too, and the Earth is spinning around, and we get this fancy thing called the Coriolis effect. And what ends up happening, because the Earth is spinning around and that air pressure is trying to get from the high pressure to low pressure, essentially we get a bit of a circulation that happens. And so it doesn't come over directly. Instead, the winds are trying to go straight from high pressure to low pressure, but with the spin of the Earth, basically everything is trying to go in a circle here around this high pressure and a circle around the low pressure. So what ends up happening is that you get the wind that ends up basically forming these shapes and it's going to be coming straight down from this high pressure, and it's going to be wrapping around this low pressure and kind of swirling in towards this low pressure like this. So it does kind of this, these little pockets of air end up taking quite the trip around the United States. And so we get air from all over the place. And this is important because we've got spots out, say in the desert Southwest, it's hot and dry air out there. Well, that air is trying to get pulled into these fronts. We get warm moisture from the Gulf of Mexico. It gets lifted off towards our area here. And so we're getting air that is from the ocean that's traveled hundreds and hundreds of miles from, say, Louisiana and down towards Texas. And that's really important because that is one of the reasons that we end up having great farmland around the Great Lakes and the Midwest. We've got some amazing areas here to where we can plant a lot of crops, and we have some very fertile grounds all the way through the Great Lakes and the Midwest. And that has to do with somewhat our location compared to the Gulf of Mexico, but it has to do with these storm systems pulling in all this warm and humid air. So it has all these circulations are happening, but basically what's going on here is this air wants to go from high to low pressure, and it's going to find its way around it. And the more intense this low pressure is, and the more intense this high pressure is, the more wind there's going to be. And yesterday there was a lot, and this map did not look a whole lot different. This low pressure was right up in here. This high pressure was right out in here, and we were stuck right here, and those winds were coming, circulating right around that area of low pressure really, really fast, and that's why we had all those strong winds yesterday. But there's something else that's happening too, as all the wind, it rushes towards this area of low pressure. Once all of it's kind of circulating into the same spot, right? Well, when all that air comes together, think of it, if your hands come together and everything is going to collide, all of a sudden you can't go together anymore. Everything is coming straight in together. It's either got to go up, or it's got to go down. And if you're already at the ground level, it can't go down anymore. So that air that comes together only has one direction to go, and it's up into the sky. And that's very important because we talked yesterday a little bit about how these clouds develop. You need upward motion to get them to develop. And that area of low pressure, all the air is coming together, and once it gets together, it has to rise. And it just continues to do this, and it just keeps going up and up and up. And that's how we get clouds, and that's how we get crummy weather, rain, snow, all of it. High pressure, on the other hand, the air is sinking. It's going down, essentially. And so because of that, we get dry air, and we don't really get a whole lot of clouds with it. So that's why a lot of times, just by having a barometer and looking at the clouds, you can get a good idea what the forecast is going to do. Because a barometer is measuring how high or low the pressure is. And if the pressure is dropping, then we know we have lower pressure coming in and a better ability to get clouds to develop and rain to develop. And then by watching the cloud types, we can get an idea of what kind of weather we may be looking at in the next 12, 24, 36, maybe 48 hours. So there's a lot that you can already pick out just by looking at the clouds and just by measuring if the pressure is low or if it is high, which is really important. In fact, that's before we had computers, before we had satellite, before we had all these weather tools. That's how a lot of these forecasts were put together. A lot of it by the barometer and just watching the winds and the clouds. So fronts are another thing too that have a lot to do with our weather. And this is a stage here, so we're kind of looking at these diagrams, and it's going to be a lot easier when we go through the weather maps. But it starts off with you got some colder weather that's kind of sitting in place, and you got some warmer weather. And everything's somewhat stable. There's not really a whole lot going on. And then we go over to this B one here, just over towards the right of it. And in that picture here, all of a sudden there's just a little bit of wave here, just some little disturbance in the atmosphere between those two. And that's where everything gets going. And then back over in C, so we'll go over to the corner. Once we start to get a little wave going, we can finally get that area of low pressure to start to circulate. If we already have kind of the beginnings of it going, then that air is going to start circulating around that low pressure, and it's going to pull the cold air down, and it's going to pull the warm air up towards the north. And so now we start getting these distinct fronts, the distinct boundaries, sharp boundaries sometimes, of where the cold and the hot air is. And they're coming together, and that creates a big battle in the atmosphere. And in fact, that's how these fronts were developed. That's how the whole name came about. You go back towards World War I, and a lot of weather forecasting ability was come up with by that point. And when they went off to war, they would form a front. And that's essentially kind of how this was all designed, is that this front is the boundary between the warm air and the cold air. And you can see it here developing, and it gets going, and eventually it circulates together so much, the warm air and cold air kind of come together and it all falls apart. And that's the life cycle of when it comes to these fronts and these storm systems that develop for us. So here's a look at some different weather maps, and I try to put it in. We're looking at the side of the front and we're looking at it from the top like we would from a weather map. So we'll start up at the top, and here's our low pressure that's getting organized. Here's our cold air that's coming down. Let me pick a different color here. We'll go with purple. That might be a little better. But we get that cold air that's coming down from Canada. It pulls the warm air up to the north. But as it's doing that, you get the big temperature difference. But over here on the corner, you kind of see what's happening. It all has to do with cold air is dense. So think of cold air like a rock. If you take a rock, it's going to drop really quick down to the ground, right? If I've got a feather, it's just going to kind of float. It's lighter. It's kind of be moved around a little bit easier. The feather is like our hot air. The rock is like our cold air. It's real dense. So that cold air likes to go and hug right next to the ground. So here's our cold front, and when it comes in, it's a sharp division on that cold air. And it takes the warm air and it moves it real quick. Kind of like the feather, we can move it real quick, and it pushes that warm air up, basically up above it. And so it can form these storm clouds right along the cold front. It creates that intense lift that we need to get going, and that intense lift can cause a whole line of thunderstorms to develop. But then where the warm front is at, that cool air is trying to gradually move out. It is taking its time. The warm air instead can't push it out because it's too light, so it just starts to go up above it and starts to rise. And as it does, it starts forming these clouds way out ahead of it. And that's why we can look at clouds and get an idea what the forecast is going to do and how it's going to change maybe 2 days in advance, because we start seeing these high clouds first, and then it comes down into some mid-level clouds, and eventually we get our rain clouds that come in as that front comes in. So both the warm air, anytime you get the big warm air and the cold air to come together like that, you create lift, which creates clouds and showers and storms. Eventually, the storm system, these fronts collide. That's that purple front here. I don't show that on TV too often, but it does happen more often than what we show. That's called an occluded front. And both fronts come together. And when they collide together, what it does is it lifts this pocket of warm air into the sky. And so now you've got a whole area here that's just really good for rain making, but it never really gets that warm at the ground, but that warm air is lifted up. And then eventually down at the bottom here, the storm starts to fall apart. And once that purple front takes over dramatically like it does in here, eventually the whole storm system just kind of dies out. There's not a whole lot of intensity left. So these are really important clues that can help us forecast the weather if we look at these different fronts. So here's a setup like we might have, a very typical setup in the springtime. And while we haven't talked a whole lot about the jet stream, I'll have the jet stream on this particular map, and you can kind of see it moving across the country. Jet stream's like a big river of air, and it likes to push these storms across the country. But ignoring that jet stream there, here's our big low pressure. That is our storm. That is the center of our storm that is forming here and moving across the country. And then here's our sharp cold front that's moving in. Here's our warm front. And this is what happens all the time here. It's nice and cool across the Great Lakes. We get the push of some warm air that tries to come into Indiana, tries to come into Ohio, eventually tries to work its way to Michigan. We get some clouds, we get some showers. The warm front lifts to the north. That's when we get our thunderstorms, maybe even severe weather, and then we get a rush of cold air back behind it. And I know somebody was asking me about the dry front, which is actually dry line, but that's what this is down here. And this is what fires off severe storms a lot down in Texas this time of the year. May, it starts to move into parts of Oklahoma and then Kansas and eventually Nebraska. But this is a big battle zone out in the middle part of the country that acts like a front, but the front never really moves anywhere. But that's that hot and dry air. That's another collision point that allows a lot of things to go up into the sky. So it's all these fronts and low pressures, what they're doing is giving us an ability for things to go up into the sky. So this is the same weather map, and now we have different weather conditions on it that is pretty typical what's happening. So there's a lot of things going on here, but this green section here, which I already kind of pointed out a little bit, but that's where we got rain at. And down here, down in Texas, we got some thunderstorms. across Indiana and Ohio. These are general showers. You might even have some snow back off to the northwest. This is exactly what happened over the last few days. Parts of the Dakotas, Minnesota, Wisconsin, and northern Michigan got a bunch of snow out of it. And then you've got some nice weather out here in Arizona and New Mexico. Actually, it gets to be pretty hot this time of the year as they're transitioning to some very dry weather. All right, so that's typically what it looks like. I want to go right into it and show you. This is kind of a crazy looking map. It's going to get simpler here for us, but this is what the weather map looked like last Friday. Now, I know we're going back, but if you did your observations and you got them written down on your sheet, you might be able to pull that out and get a good look here of what the weather was doing. So that green, well, that was rain. And it wasn't raining through every single spot of that area, but that was where we had a lot of scattered showers and storms. Here was the snow back to the north and west. Here's our low pressure. It was almost in the same spot, almost like exactly as I was showing you that typical spring setup. Our classic warm front is down here at this point across the south. And that was a spot where we had severe weather that developed Friday, but especially as we got into Sunday, Easter Sunday. There's a lot of bad storms down here that were developing. And then our cold front works our way up here, high pressure's up in here, and it's pushing down all this cold air here from Canada. So just by looking at this weather map, even if we don't have where the rain is at, we can get a pretty good idea of how the temperatures may change with time. In fact, that was last Friday. I'm gonna keep rolling through and show you what happened after that. Remember how windy it was yesterday? Well, this is the weather map yesterday. We've got that big storm system. Look how close it came to us, and then it moved right up into the northern, right into Ontario. And then our high pressures clear out to the west, and it moved down right in the middle part of the country. And so these black lines here that you see, these are pressure lines. So you see them here. And the closer these pressure lines get to one another, look how close they get. That's a lot of pressure lines. That is very unusual. That means that there's a lot of wind that is going to be in this area. I could just look at this map right now and tell you it was windy all the way through here, this part of the country, basically the whole eastern part of the country, and we were right in the middle of it yesterday. That's why we had a big windstorm to go along with it. But you can see about where the rain was. Here's the snow that was up in UP, Michigan, 1 to 2 feet, by the way. That is a lot of snow. They had the severe weather that moved out here across the southern part of the country. And so that was yesterday's weather map. And you can see just by looking at this, you can probably tell it's about to get really cold. Here's our cold front that went through right here. Our winds are coming right in from Canada, driving in back behind the system. So just by looking at this, we may not know the exact temperature, but we can get a good idea that we're going to have some colder weather that's going to start to move back in. Now, this is going forward here, looking closer to what it was this morning. Still some snow lingering here into the UP, high pressure out towards the west. Not as bad of weather. There's still just a little bit of some wet weather and some clouds here that are trying to move in. We won't get the rain, but the clouds will try to move in later on for today. And then going forward, it's not nearly as active here on those weather maps, but high pressure is still in control, and the winds like to come down. Here from the north, right on this side of the low pressure. So that's keeping that chilly weather around into the eastern part of the country. So that's a look at fronts and how pressure systems all kind of work together. I know there's a lot there, but basically you see the red L, that's a lower pressure. And that essentially means that the air is going up. If the air is going up, it's going to form clouds. It's going to form rain, snow, possibly thunderstorms. Fronts are another good spot for that. Warm fronts, typically we can get some fog, we get some low clouds, a steady rain. Those are our nimbostratus clouds that we talked about yesterday, the big rain cloud. And then cold fronts usually have a lot of those cumulonimbus clouds. If it's unstable enough, that's our thunderstorm cloud. And then back behind it, it gets much colder when we get these storm systems to go through. The big blue H, that usually means nice weather. Sometimes cold weather, but usually it's not all that bad back behind those fronts. So that's a look at the different weather maps, and hopefully you can start to kind of see some of these pieces going together. So tomorrow what we're going to do is I'm going to go over, and this is exactly how we put a forecast together. We're going to look at the weather conditions that we've had over the past day or two, meaning where we've been. This is where those observations have become really important, right? We look at the weather, we observe the weather, we understand what's happening with it, and that kind of helps us already have in our mind what's going on with the weather here. So we want to know what the weather is doing here, and we keep those observations that really help out. And then we want to look at satellite, we want to look at radar, we look at our weather tools that we talked about to see how the weather is going to change. And then after that, we will start looking at these different weather maps to kind of see, okay, what's the weather doing, how's it going to change? And then we look at our computer models. That's our super calculator that's solving the answers but giving us weather maps instead of numbers. And then we can kind of go through and get an idea of how things are going to change. So tomorrow, that's exactly what we're going to do. I'm going to come in, I'm going to do my normal job tomorrow, go on early tomorrow morning. But as I'm putting all the weather data and gathering all the weather data, I'm going to collect that, and we're going to go through the whole forecast process together tomorrow. So make sure tomorrow, when you come, have a full sheet of paper, if you can. It could be computer paper, it could be notebook paper, it can be construction paper. It doesn't really matter, whatever you want. In fact, construction paper, it'll be colorful, maybe that's even better. And then come with a pen, a marker, a crayon even, it doesn't really matter. Something to write with and something to write on. And then tomorrow we'll divide up our paper, we're gonna write down our notes on what the weather's doing, and then we're gonna have a 4-day forecast we're gonna put together. And here's the fun thing, we've got a challenging forecast on Friday that may include snow, and our computer models right now don't all agree with where this storm's going to go and how much is going to add up. So you're going to help me tomorrow with this forecast on how things are looking. It's going to be great because we're going to look at some new computer models, a new weather data that comes in right before the noon show. And so we'll do it all together. It'll help out. And when you're done with that forecast, take a picture of it, send it to me. Either in the comments section tomorrow or mom or dad sending that or whatever. So again, we're going to go through all that tomorrow. As for today, though, of course, question time. Any questions that you have, feel free, whether it's anything we've talked about, something we haven't talked about weather-wise, let's go for it. So let's see what we've got here so far. Let's see. Okay, Muhammad asking, what is an occluded front? So let me go back. Let me try to go back and then describe it once again here for us. So an occluded front, it's something we don't talk about. There's 4 different types of fronts, and I didn't go through and label all of them here, but I'm going to, it won't take me that long to do so. So let me get back to the best picture I can to kind of show it. All right, so we have our cold front, which we talked about. So that means that it's the leading edge of the cold air. This is all of our cold air. I need a different color here. Let's go this one right here. So we've got all of our cold air back to the west on this one. We got warm air out ahead of it. So cold front means we're on the leading edge of the cold air. Warm front means we're on the leading edge of the warm air. So this would be warm air all in here. Stationary front means that we have basically the battle between the warm and the cold air is at a stalemate. And so the front, if this front stopped moving, this warm front stopped moving, that would be a stationary front, meaning that it's not moving. We've got cold air on the one side, warm air on the other side. Same thing with this cold front. If it stopped moving, it would be a stationary front because it isn't moving. So an occluded front here is what's happening when we go from A over to B. So here's A, and then the next one is B. What happens is that the warm air, it moves much slower than the cold air when it comes in. So a warm front is going to move a lot slower than the cold front. So eventually, this cold front is going to catch up with the warm front. And when it does, you see this purple front here, and this down on C, the purple front's much bigger. But what's happening is the 2 fronts are colliding. The cold front is literally running right into the warm front, and it's taking that warm air and it's lifting it above the ground. So in A, we've got on this side of it, we've got the cold air back off to the west. We've got the warm air here that is in the middle, and then we've got some cool air out ahead of it. So we've got our warm front, we've got our cold front, and then the next one down, here's our cold air, here's our warm air. It has literally lifted this pocket of warm air above the ground, which is pretty neat. So on the surface, it's still cold all the way through. We can't even detect what's going on. That's one reason why we have to look at these weather balloons. They send up all these observations because if we have no idea that there's a front, that warm air that's been lifted above the ground, we could miss a forecast big time. And so an occluded front is a cold front that runs into a warm front, and it takes the warm air and it lifts it above the ground, but it can still produce quite a bit of rain. Okay, let's see here. Oh, let me see. Hold on here. Hold on. So I'm drawing, looks like I'm drawing all this stuff and you guys couldn't even see it. So that probably did. Mohammed, let me go back and explain this real briefly again. I apologize totally. So it looks like we're good to go. We've got it up here. So in A here, so again, here's our cold front, and then here's our warm front out ahead of it. The cold front is moving so quick that by the time we get down to B, that cold front is essentially slamming into the warm front. It happens close to low pressure first, and eventually, as you go down into C, you can see there's a bigger area where it's a purple front, and that's our occluded front. And so on A, if we go over to the side, I think that does a little better job. We're kind of slicing this in right apart. Here's our cold air, and then here's our warm air. And so it's lifting that warm air above the ground. So it's still cold all the way on the surface, but it's lifting that warm air above the ground, and that's where you've got your rain area that ends up forming here. Let's see. All right, Samantha Meyer asking, our cloud fronts, I wasn't here for a bit. So what we're talking about, we're talking about cold fronts, warm fronts, even stationary fronts and occluded fronts. But fronts in general are usually areas where we have clouds, and a lot of times we have rain along it, because what it's doing is it is lifting up that air. And anytime we can lift the air up, we've got a really good chance of getting clouds and also a good chance of getting rain. And by the way, we talked about fronts being a great spot for that, as they are a lot of the times. Low pressure is a great spot for that. Mountains are a great spot for that. Think about if the air is strong enough, if the wind is strong enough, and it's going right into the mountains, and it hits the mountains. Well, maybe this is a better way of describing, but if the air is coming right in, it hits the mountains, it's got to go straight up. It can't go down, it can't go to the side, the air has to go up. So if there's enough moisture with it, a lot of times not only does it produce clouds, but it produces rain or produces snow, and that is the reason why you have all these ski resorts that are in the mountains. Of course, skiing downhill is more fun than just skiing on flat ground, but outside of that, they get a lot of snow. Think of Tennessee, the mountains of Tennessee and West Virginia. They're a lot farther south than us, and those mountaintops get a lot more snow than what we get. And it's because when it is cold and the wind's coming out of the northwest, it hits it directly, the air goes up, and it cools, and it forms a lot of those clouds and snow. So Jennifer asking, can cold and warm fronts produce tornadoes? They can. Now, they don't produce the tornadoes themselves. They produce the ingredients for that air to go up and rise. And then if we have the other ingredients in place, we can get thunderstorms and then eventually tornadoes. But for us, what we're looking at a lot of times is that cold fronts are a great spot for thunderstorms to fire off. And so that is a common spot where we have lines of storms develop. And sometimes those storms are severe and they can produce hail, and damaging winds happen a lot along cold fronts, sometimes tornadoes. Usually there's lots of instability, which means there's lots of lift along a cold front. And a lot of times there's not enough wind shear to help twist the storms and rotate them around. Warm fronts are different. Warm fronts, usually there's a lot of wind shear along the warm front, because the winds just north of the front are more out of the east or southeast, and the winds just to the south are generally straight out of the south or southwest. And so the winds are aligned usually to really kind of twist these storms around, but there's also typically not as much instability and lift along a warm front as there is on a cold front. A cold front usually has more lift. So it just depends on those ingredients, how they come together, but both can lead to storms that produce tornadoes, depending on the other ingredients that are there. Where do fronts normally hit? Fronts are common right through the continental United States, and we get them all the time. When I say continental United States, I'm talking about the lower 48 states that you see. I'm not talking about Hawaii. They have different types of something we're going to talk about here in a few weeks, somewhere in May. We're going to talk about regional weather and how we get lake breezes. The ocean gets sea breezes. It's the same basic thing. Those are basically like little miniature fronts that happen that are there all the time. So we'll talk about how Hawaii is a little different and how some other spots are different. But these fronts don't typically happen as much in the polar cold spots, and they don't happen as much in the tropical regions of the Earth, but they happen right in between. We call them middle latitudes. They happen all the time. And so we probably, my goodness, I have to think of how many fronts, this time of the year especially, we can get lots and lots of fronts, and the same thing in the wintertime. we get quite a bit. We don't get as many in the summer because everything kind of heats up. There's not a big divide between the cold air and the warm air as much, but we get it a lot. And not only do we get it a lot, but most of the United States gets fronts quite a bit. So that was from Julie. April, so this is Colin asking, do the hot air make rain hot? That's a good question. So the temperature of the raindrops has a lot to do with where the temperature is a little bit higher up off the ground. So if you've ever been outside on a hot day and notice that the rain's kind of cold, well, there's a reason for that. And the reason for it is that the air above our heads is colder. And so because it does take water longer to warm up or to cool down than it takes the surrounding air, that temperature is going to usually be colder with the rain than it is towards the ground. Now, snow can be a little different, and I know that if it's below freezing, usually it doesn't really matter, but sometimes in the wintertime, it's common for us to get some warm air that ends up coming in. It comes in real quick, kind of like along that warm front, and the winds just push it straight in above our head. The problem is, at the bottom, that warm front hasn't gone through yet. And so we get cold air trapped at the bottom near the ground. There's warm air that comes above it. Snow falls into the warm air, it melts it into rain. Now the rain falls into the cold air, and now we got a problem because the temperatures, again, are a little bit warmer on the raindrops than it is on the surrounding air. And so if there's a lot of time in there, those raindrops could refreeze into ice pellets and then coat the ground. But what happens more often than that usually is that there isn't enough time there. Raindrops are cold, but they're not nearly as cold as the ground, and then it comes down and it hits the ground and it coats everything in ice. Now, we had a little bit of that this winter, but we had a lot of it last winter in that one ice storm that we got in particular, and just coats everything in kind of a glassy look of ice. So the temperature of the raindrop or even the snowflake has to do with the air temperature above our heads more so than anything. Courtney's saying, can you show us the green wall? Let me see what I can do. I would have to end the live stream to do anything better than this. So I'll just try to show you in that little camera. If you can see, that's our green wall right over there. And I'll have to remember, maybe tomorrow I'll try to set things up to where I can have a camera or kind of a full screen camera so you can see a little bit better. But that's our green wall over there, and it's actually pretty big. This is I know a small camera clear on the bottom of the screen, but you've got the things hanging down, the things kind of hanging down there more on the right as I'm looking at this screen is our camera that is pointed towards us. So it's actually, if you look at it, underneath that camera and that monitor, there's nothing on the ground, which is pretty cool. And here it goes straight, there's a pole that goes straight up into the rafter, and it holds that into place, which is pretty neat. So there's nothing on the ground. Actually, it's like that for the rest of the studio. So I'll just kind of turn it around. There's the anchor desk. By the way, nobody else in here with me at this point. But the ground is totally free, but all of those cameras that you see, they're all connected to the top of the rafters, which is pretty neat. So I'll point it back over here. I'll have to remember to put that on a full screen. Unfortunately, I can't do it though today. What's the state that gets the most fronts? That's a good question. I would, if we're including dry lines in there, which is a type of front, essentially, it's a boundary. It's the division between the hot and moist, well, the hot and dry air out in the desert Southwest and the warm and moist air, the warm and humid air that comes in off the Gulf of Mexico. So if we include that, I would say Texas and Oklahoma and probably Kansas, right out in that part of the country. Because if they get these storm systems, like these low pressure centers, like to develop on the east side of the Rocky Mountains. This is usually where they get organized. So you get low pressure that kind of goes over the mountains, but then as it moves just east of Denver, the low pressure begins to strengthen. It starts to pull in the cold air from Canada down towards the north. It pulls in the warm, moist air from the Gulf of Mexico, and it pulls in the hot, dry air out from the desert Southwest. And so now you've got the perfect ingredients and everything for that storm system to take off, and usually it tracks from like the panhandle of Texas and it'll come up our way, and then we'll deal with it, and it ends up in New England before it goes off to the Atlantic Ocean. So based off of that, if you're just including that extra dry line, which is usually out kind of in the middle of the plains or western part of the plains, I would have to say Oklahoma, Texas, Kansas is probably a good spot where they would see more fronts than probably most. But then in the summertime, they don't really get a whole lot. The dry line's still kind of hanging around, but once it gets hot enough, everything kind of lifts north into southern Canada by that point. All right. All right, sounds good. It looks like we've answered most of the questions. If I've missed some, I apologize. We'll be back tomorrow. Ask it again. Thank you for everybody that's been sending in the observations, taking a picture of that from last week and sending them in. I appreciate it. It's good to see. If you haven't sent yours in yet, go ahead, still do it. You can send it to me in a comment right here on this page. If you can't find that, just go to my Facebook page, Meteorologist Ross Ellett. You can send it to me in a private message. You can send it to me in a comment. Post it on my wall there, whatever you want to do. But looking forward to seeing that, and really looking forward to forecasting tomorrow. So again, make sure to grab a sheet of paper, notebook paper, computer paper, construction paper. I don't care what paper it is. It can be colorful. It doesn't have to be colorful. Grab something to write with. Tomorrow will be a lot of fun, and we'll put a forecast together. And I want to see the pictures of the forecast because we're going to keep an eye on it and see how everything goes. And then we're going to look through some of those coming up the following week as we start to talk, right before we start talking about space weather. So should be a lot of fun. Looking forward to it. We'll see you tomorrow.